So this is going to be a little bit longer video because I want to put all of this stuff together so you understand why it works the way it does and why we're forcing you to do it. So, hold on, I'm looking for a pencil. You can just be patient. Evidently, I'm going to keep looking because I don't see one. Oh, found it. All right. So, we have rational zeros theorem. Will tell you possible pretty answers. Pretty answers or solutions, which are also x-intercepts, which are also zeros. Zeros. Okay? So that is rational zeros theorem. Basically, remember that ratio is the first 5 letters. This is going to give you a list. Instead of saying, I have no idea where this thing crosses the x-axis, this will give you a list of pretty places to try. This will not include stuff like the square root of 2 or the square root of 7 or anything like that. Okay? So it's going to end up, it's also not going to be irrational numbers like pi or e or anything like that. So this is just going to be the pretty answers, so the ratio of 2 integers. The ratio of 2 integers, okay? Descartes' rule of signs will tell me how many positives and how many negatives to look for. And the linear factors theorem or the linear factorization theorem will tell us that I can break down every polynomial into factors that are linear. Okay, factors that are linear. So we've got rational zeros theorem. We have Descartes, like day, like night and day, and cart, like a shopping cart. Descartes' rule of signs. And then linear factors theorem or linear factorization theorem. So I have already made up a polynomial for you. And my polynomial is an x to the third plus a 4x squared plus an x minus 6. And I would like to know where this thing hits the x-axis. So the first thing you should recognize is the degree of the polynomial, which is a 3, is how many solutions we're going to find. So we're looking for 3, okay? Well, this is not factorable the way it stands. So I need to figure out where this thing could cross, because right now, for all I know, it crosses at 97. Okay, for all I know, it crosses at negative 400 bajillion. I don't know. So I want to narrow this thing down to a list of possibilities that I can factor. So if I use the rational zeros theorem, what you're going to do is take the last number, I don't care if it's positive or negative, take the last number once it's in descending order, and then take the first number, which in this case is a 1, and make that your denominator. So it's last over first. And now break down the factors. What can I multiply together to get 6? I can do 1 and 6, and I can do 2 and 3. That was lovely. 1, 2, 3, and 6. What can I multiply together to get 1? Well, I can multiply 1. Okay? So this is the pile that I'm going to choose to pull from. And now here's why I didn't care that this was negative. My rational zeros theorem will give me solutions that are positive or negative. So I'm going to be very methodical. I'm going to take everything in the top over the first factor in the bottom. Everything in the top over the second factor in the bottom. Well, notice I've only got one factor this time. Okay? So I've got a 1 over 1, a 2 over 1, a 3 over 1, and a 6 over 1. So I've just narrowed it down from an infinite number of places where this could cross in a pretty spot to only 8. And you're thinking, but I only see 4. But remember, these can be positive or negative. So I've got positive 1, negative 1, positive 2, negative 2, positive 3, negative 3, positive 6, negative 6. Okay, so this is where I'm going to start pulling from. The next thing I want to look at is how many of each I'm going to find. So Descartes' rule of signs. What I'm going to do first is just count the sign changes from left to right. So I have a positive x to the third. I have a positive 4x squared. I have a positive x. And I have a negative 6. And now you're going to count the sign changes. So I start off positive. Well, I'm staying positive. I stayed positive. Oh, wait, I changed. I have one sign change. I am guaranteed one positive answer. I know I will have one positive answer, which means if I'm guessing and checking, I don't have to find any more than one. If I find one positive answer, I don't have to look for any more. Okay? My dog was scratching at the door. All right, so for negatives, what I'm going to do is I'm going to keep my coefficients. So I'm going to keep a positive 1, positive 4, positive 1, and a negative. And then I am going to substitute in negative values for my x's. I don't care what happens with the numbers. I care what happens with the signs. So I'm going to go ahead and start off with my positive 1 exponent. Then I've got a positive 4 exponent. I've got another positive 1 exponent. And then I've got a negative 6 exponent. But notice now that I am now going to put in negatives for my x's. So I have a negative to the third. I have a negative squared. I have a negative. Okay, and then he's just going to stay. So I kind of notice I've spaced him out just a little bit. So I can remember that this is a term, this is a term, this is a term, and this is a term. So I want to know what happens to this term. So I'm going to look at this first. I've got a positive, a negative times a negative times a negative, because it's a negative cubed. So a negative times a negative times a negative is negative. Okay, so let's move to the next term. A positive, a negative times a negative, negative squared, is positive. This is going to lead off positive, and then I've got a negative, and then this is going to stay negative. So what do I know about each term? This term is going to go negative. This term is going to go positive. This term is going to go negative, and this term is going to go negative. It's stay negative. Okay, so all I did was keep my coefficients, the signs on them, but then wherever there was an x, I placed a negative just to see what would happen to the sign of each term. So now what am I going to do? I'm going to count my sign changes. So I started off negative. Ooh, I changed. Okay. Now I'm starting off positive. Ooh, I changed. Okay. Now I'm starting off negative. Oop, I stayed the same. So how many sign changes do you have? I have 2 sign changes. Okay, so this is where it gets weird. What that means is so far for positive answers, I know I'm going to have a quantity of 1 positive answer. Okay. For negative answers, I will either have 2, or I need to count backwards by 2's. I will either have 2 or none. Okay, so think about that. If I've got 1 positive and 2 negative, that's going to give me my 3 solutions. If I've got one positive and no negative, that means the other 2 would be complex, which is the plus or minus imaginary stuff. They would be imaginary solutions or complex solutions. And it's just easier to say complex. Okay, so that's what I know. Now I want to know actually what my solutions are. Okay, so we're going to compare what we get for an answer based on what I found here. So I'm going to flip my page. So my page says I have an x to the third. Okay, I forgot what my polynomial was. 4x squared minus x plus x minus 6. So this is my polynomial. I want to know where he crosses the axis. So I am going to pull numbers from my list of questions over here. And I'm just going to start diving in. I always start with 1 and move out. Okay, so let's start with 1. Let's see if 1 works. And I'm going to use synthetic division to see if 1 works. So drop your first term and then multiply. So 1 times 1 is 1. That gives me a 5. Okay. 1 times 5 is 5. That gives me a 6. 1 times 6 is 6. That gives me a 0. So what you just found out was that 1 divides out of there evenly with a remainder of 0. So 1 worked. You got an answer of 1. So that's one of my answers. Solutions. One of them's a 1. Okay, so it crosses the x-axis at 1. Now what do I need to do? I just divided out a 1, which means this is now an x squared. This row was an x to the third. This is now an x squared. So if I fill that back in, you will notice, because I created this thing, that this is factorable. So two numbers that multiply to 6 that add up to 5 are going to be an x plus 2, x plus 3, which means my two solutions, what am I doing, will be x plus 3 is 0. I would subtract 2, and I would subtract 3. So x is negative 3. So you got two more solutions. One of them is at negative 2, one of them is at negative 3. So I have negative 2, I have negative 3. Those are your solutions. Look at this magic. Okay? If I look in my pile, was positive 1 in my pile? Yes, it was. Was negative 2 in my pile? Yes, it was. And if you're not seeing that, let me just write this out real quick. Your possibilities are negative 1 and positive 1, negative 2 and positive 2, negative 3 and positive 3, negative 6 and positive 6. So this is rational zeros theorem. I got 3 solutions that happen to be pretty. I got a solution of 1, of negative 2, and of negative 3. All of those were in my pile to start with. Okay? 4 was not in my pile. I wouldn't have tried 4 because he's not a possibility. So rational zeros theorem worked. Now let's look at Descartes' rule of signs. Descartes' rule of signs said I was going to get 1 positive answer and either 2 negatives or no negatives. So what did I get? Other than turning the wrong way. I got 1 positive and 2 negatives. Okay, so if I hadn't gotten the negatives, then I wouldn't have had another positive. I would have had a positive and 2 imaginary. Okay, so that's what Descartes' rule of signs says. Now, let's finish this thing up with the linear factors theorem. Linear factors theorem says I can now break this down as 3 distinct factors. Okay, so what are these 2 factors? I already know what they are. One of them is an x plus 2. The other is an x plus 3. And then this one, if 1 is your solution, then x minus 1 would be your factor. So how many solutions was I looking for? I was looking for 3. How many factors am I looking for? I'm looking for 3. Okay? If any of these factors were to match, so let's just say, new problem. Let's say I had an x plus 1, x plus 1, x minus 7. Then I could write that as an x plus 1 squared times x minus 7. So there are still 3 factors there. I'm just lazy and write this one as 1. And then what do we know about linear factors? If I were to graph y equals x minus 1, it makes a line. If I were to graph y equals x plus 2, it makes a line. If I were to graph y equals x plus 3, it makes a line. How do you know? Because every exponent on the inside of the parentheses has an exponent of 1. Okay? Every variable has an exponent of 1. So that is the bigger picture of what you're doing, because while you are working through this assignment, or while you're going to be doing weird stuff. You're going to be thinking, why am I doing it? Well, now you know. So let me know if you got questions.